Hello everyone and welcome to today's Fusion 360 live stream. I'm going to be your host. My name is Jason Lichtman and I'm a technical specialist here at Autodesk in colorful Colorado. And today we're going to be talking about designing wooden living hinges, and our example is going to be a really cool eyeglass case. And in case you guys don't know, a few months ago I designed a pair of eyeglasses. It's the glasses I'm wearing right now, these prescription glasses, and I had them 3D printed. They fit great, they look great, I'm super happy with them, but I decided I really wanted a cool case to be able to store them to make sure that they're staying protected, but also looking really cool. And I thought, why don't I take two things that I like a lot and bring them together to make it really awesome? So if you think about wooden living hinges, well, first of all, what are they? Wooden living hinges is the ability to take a flat piece of wood and to cut it in certain ways to be able to make it bend into shape. So if you start off with a piece of flat wood like this happens to be a coaster made out of plywood. You can see that it is a rigid coaster, just like you'd expect. And that same piece of wood can actually be turned into a piece like this that actually can bend quite a bit. And we're going to show you how to do that today. So for the agenda, we're going to talk a little bit about wooden living hinges, what preparation that you should have before you go and start designing things that have wooden living hinges in them. And then we're going to go step by step through how to actually design this case, all the way from the design to the cam. And by cam, I mean actually creating tool paths for the laser to actually follow. And that's going to include something called a kerf offset. Now, this is a more advanced course, so I'm expecting you guys to have a basic knowledge of Fusion 360 and some of the basic terminology that I'm going to use today. And if you don't already have that, that's fine. I'm sure you're still going to learn a thing or two along the way, but this is definitely going to be a more advanced topic. Now, while I am presenting, in the background we have Aaron Magnin. He's our technical marketing ninja out of our San Francisco office, and he's going to be on the computer answering any questions you have along the way. So just keep in mind that he's going to be answering them, not me. I'm happy to answer them after our live stream is over. All right. Now I do have a request from all of you out there. I'm expecting you to learn quite a few pretty awesome things today, and each time you learn something new, my request is that in the comments section you just type in the number that corresponds to how many things you learned. So after you learn something for the first time, of course, just type in the number 1 and hit enter and put that in the comment. And if you can get to learning 10 different things today, that would be awesome. In that case, you would just type in 10 into the comment section. I want to see how high we can get up today and how many comments we can get based on how much you guys are learning out there. All right, so let's jump into the really good stuff. So I already talked a little bit about what the living hinge is. But how are we actually going to make it happen? Well, first let me tell you this. I started my first living hinge project. I designed everything that I was trying to design. I lasered it, and then once it was done, finished in the laser, I went to go bend it to shape, and the part broke right in front of me. And I was a little bit shocked, but I shouldn't have been. And the reason I shouldn't have been shocked is because I made a lot of guesses along the way, and I never verified that any of those guesses were accurate. So the key here really is preparation, and we want to make sure to be well prepared so that our project is going to be successful. And again, the reason that I wasn't successful was because I took a living hinge pattern from the internet, I applied it to a particular project that I wanted to work on, and I expected it to work, but it didn't. So what kinds of things might you want to do to prepare? And what I'm going to show you might seem quite elaborate, but I assure you that if you want to be successful, this is one strategy that will pretty much guarantee success. And that strategy is to start off with what I would call swatches. And so in front of me, and you can't see this in detail, but I'm going to switch my camera over to the computer and you'll see this in just a second. I have a variety of different swatches, and each one is a completely different pattern that is a perfectly suitable living hinge pattern. You can find these patterns on the internet very easily. They're primarily free, although some of them you can pay for as well. And you could also, of course, design your own patterns. And what I did here was, instead of just taking these patterns and putting them in my computer and looking them on the computer, I actually applied the pattern to a laser cut piece of wood that's the same material that I actually want to use in real life. So in this case, I have a variety of different patterns, and each one looks different. Actually, before I show you bending them, let me show you what they look like on the computer. Let's go over to the computer. We're going to jump over to Adobe Illustrator, and we'll jump right over here to all of our swatches. And here you could see a collection of different swatches that I have available. The colors, by the way, that you see on the screen at the moment, those are just the order that the laser is going to use to actually cut. And it also controls what kind of things I'm going to cut versus score and things like that. But in general, here I have a collection of different patterns, and we could see that I have a variety of additional ones as well. But the key is, I want to see what they're going to look like in real life. And more important than what are they going to look like, I want to see what are they going to feel like in real life. So let's go and try that out. Perfect. So here's one example. This is the bowling pin pattern. Looks really great, and I could see that it's pretty bendable, right? It actually is quite bendable. The diamond pattern, on the other hand, is even more bendable. But I'll tell you, it looks pretty fragile in my opinion. Brackets look similar. This is one of my favorites. It's called fabric. And if you try to bend fabric, you'll see that it actually doesn't bend very well. So the key here really is, instead of just applying one of these patterns because I think it looks cool to my project and expecting it to bend how I expected, instead, I'm going to actually go and make these in real life, and based on how they really bend, then I know which one is probably the best choice for my particular project. Now, I am going to go a little bit further than that even. And so once you pick a pattern that you like, you can actually scale the pattern, whether you're stretching it, like by a percentage, or you're changing the spacing between those lines. And based on changing the spacing between the lines or the scale, you can actually have a big effect on the strength of the part as well as how flexible it is. So this first batch of patterns that I have, these are all different shapes that I like. This batch is actually the same shape, and each one of these is a completely different spacing. So you'll see here, I'll take the two most drastic as our examples. I have these straight line patterns. This one has a spacing of 4 millimeters, and it doesn't bend very much. Whereas this one, on the other hand, has a spacing of 1.5 millimeters between the lines, and this one actually bends quite a lot. So by trying out different scales of the pattern, I actually get a really good feeling of what's going to make the most sense for my project. But we're going to go even further than that. Because if I design my project and I have a 5 millimeter radius, it may or may not be possible to actually make this into a 5 millimeter radius, right? And the same could be true with any size radius that you might pick. So my particular preference is going to be to figure out the exact number that is the minimum bend radius for your project. And to do that, I'm going to use radius gauges. Now, you can go out and buy radius gauges. They're on the internet, they're on Amazon and McMaster-Carr and a variety of other places. But I find that I don't really like the radius gauges that are out there. And the reason is because the radius gauges are very small, and they're only showing you a very small portion of the radius you're measuring. So the chances of you getting it correct is pretty slim to none, at least in my opinion. So thankfully, I have access to a laser, right? You could tell by all of these patterns that we're working on today. And so I lasered a set of radius gauges as well. We'll go and look at one of those. Here I have my metric set of radius gauges. And the difference between these radius gauges and the ones you might buy is that each of these has a perfect 90-degree angle. And so I'm getting exactly 1/4 of a full circle of whatever size that I want. And that means that it's going to be really easy to be accurate for whatever the minimum bend radius actually is. And so my suggestion to you is that first you go and make your swatches in whatever material you like best, and then you figure out that minimum bend radius by actually using radius gauges, whether you make them on your own or not, and you take your piece of swatch, you put the radius gauge against it and see if you can get your swatch to actually match the radius gauge. And you go smaller and smaller until eventually you can't get it to match anymore. And of course, that's going to end up being your minimum bend radius, right? In this case, for this particular swatch, which is the one we're going to be using today, this is a 1.5 millimeter spacing, and the minimum bend radius, according to the gauges at least, is going to be 10 millimeters. All right, so by doing some advanced prep work, now I know the exact minimum bend radius, and I can pretty much guarantee that when I go and apply this to my project, I'm going to have great success. Awesome. Now let's get on to the actual project itself. Let's get on to the designing part of things, because I think that's a lot more interesting than the rest. So we're going to go into our screen share, and instead of looking at our swatches, let's go and look at the flat pattern that we want to see. So here we have the flat pattern. Now this is the end result that I want to get. But how do you get there? Now I'll tell you, a lot of people out there are using 2D drawing programs like Adobe Illustrator that I'm using at this very moment. Or maybe they're using something like AutoCAD LT, a fantastic Autodesk program. And if you're using either of those programs and you manage to come up with a flat pattern, as they call it, like what you see on the screen, you're still doing a lot of guessing to figure out if this is actually going to bend into the shape you want. Let's go and look at this in real life. So hold on just a moment. There we are. So this is the same flat pattern that we had on the screen. And when I bend it into shape, I could start to see that this is actually going to work really well. But if I were to just design this in 2D and then have to laser this every time I want to go and see if this is going to work out, that could be really time consuming, and more importantly, that could waste a lot of material as well as a lot of time actually using the laser, which of course is not free. So the question becomes, how do you figure out how to get to the flat pattern? And the answer to that, in my opinion, is 3D CAD with sheet metal tools. And we have a variety of sheet metal tools at our disposal. So we're going to show you how that works in Fusion 360. So here I have Fusion. And the difference here is that instead of designing a flat pattern, I'm actually designing the 3D model of what I want the final part to look like using sheet metal tools. And then at the end, I can actually flatten the result and give me a flat pattern that I could then run on the machine. So from here on forward, we're going to go and show you how to design this step by step in Fusion 360 using our sheet metal tools. And I hope you guys are excited. I know I am. All right, so we're going to start from scratch. And in this case, what we're going to do is we're going to start from scratch with my glasses design. Because after all, I want my case to fit my glasses. And here you could see this is the same 3D glasses that I'm wearing right now. These are the same glasses. And we're going to use this to design the actual, we're going to use this to design the case around it, and it'll make sure that it fits. Now, if you don't have a 3D model of your glasses, don't worry, you don't need them. You could be using a picture you took with your phone. That would work no problem. So let's go and start our new design. Actually, and I'll correct myself. For a moment there, you didn't see the screen. This is the pair of glasses that we're going to design around. And you could see that in 3D, I actually bent the arms into position, so it'll make it really easy to be able to design the glasses around this. All right, let's jump back into our video. And nope, we're going back here. Glasses time. All right, we're starting our new design. And the first thing I like to do is to turn on my origin so that I could see where I am in 3D space. And I'm also going to save my file so that I get the benefits of our autosave features. So this is going to be called eyeglass case and save. Next thing we're going to do is I'm going to open the data panel, and I'm going to take my 3D printed glasses and I'm going to drag it into my model so that I can use that as a reference to design the case around. It's perfect. I'm going to leave this in the position, and I'm also going to add a joint so that this isn't going to move. So we can go under our assemble tools and use an as-built joint between the 3D printed glasses and our assembly file. And now these glasses are not going to move by accident out of position. The next thing I'm going to do is I'm going to define some planes that are going to refer to the width of the glasses themselves. And actually, let me tell you that part of what you're going to learn today that I think is so interesting is you're going to spend a lot of time with me in our parameters table and using equations. So let's actually jump into that right away. If you don't know where the parameters table is, you can find it under Modify, Change Parameters. We'll go and move that so you can actually see this easily. And we're going to add a couple of parameters that I think are going to be valuable to this particular project. The first one we're going to add is going to be the interior length. And we're going to set this to metric, millimeter, and we're going to set this to 145 millimeters. The next thing we're going to add is going to be thickness. And this is going to be the thickness of the material that I'm using, the wood that I'm actually making this out of. And I'm going to set this to 3.05 millimeters because I've already measured the wood, and that's the measurement that I'm going to use. The next thing I'm going to add, and this is for much later, but we're still going to add it right now, is going to be the full kerf. And if you don't know the term kerf, that's the width of the cut itself, right? So a laser beam is going to actually burn in a particular width, and that's called the kerf. If you've ever used a table saw, you would know right away that whenever you cut on the table saw, the blade itself has a thickness, and that also is called the kerf. The dimension here is going to be 0.18 millimeters, and that's pretty good so far. And I don't think we need any other parameters, so we're going to leave this as is, and we're going to come back later and add more as needed. Next thing I'm going to do is I'm going to add a construction offset plane, and we're going to move this one off to the side. And for the distance, I'm actually going to set this using the parameter that I've already created. That's the interior length divided by 2. And that's looking pretty good. I'm going to make one more of those offset planes. This one's going to go in the other direction. So it's going to be minus interior length divided by 2. Perfect. Now those are looking really good. All right, so now that we have our planes, let's go and create our first sketch. And this sketch is actually going to drive the almost entirely of our model. So this is going to be important that we get this correct. So we're going to spend a little bit extra time here and make sure that this is right. We're going to right-click on our plane and say create our sketch, and we're going to start to design what we want to make. I'm going to go and use some shortcuts, so please forgive me that I'm using some shortcuts. This is going to go a little faster than you might be used to on your end, and that's fine too. And we're going to go and add another line right here, and let's add some fillets. And this is where having the minimum bend radius that we talked about before is very important. Now you might have noticed that our document is set to inches, but I keep typing in metric numbers, right? I'm clearly a millimeters kind of guy. And I told you earlier that our minimum bend radius is 10 millimeters, so we're going to go and type that in and we're good to go. But of course my display at the moment is in inches, and so maybe if I'm really going to be spending all of my time in metric, maybe I should just change my file to metric as well, and we'll go and do that as well. Perfect. Millimeter. Okay. Let's go and add some more fillets. And you'll notice that I'm not selecting multiple edges at the same time because I want to be able to control each of these fillets individually. Or at least I like that option. I am going to hide my origin, and that's going to also hide my construction planes, and now we're good to go. Now for the top of this, we're going to add a really big arc. And we're going to go and add an arc, a 3-point arc from here to here. And we're going to go and see what this looks like if it's tangent. And I don't quite think that this looks so nice, so let's actually hit escape, and we'll make a different 3-point arc, and maybe we'll actually make a couple of them combined, and I think that'll look a little bit better. Perfect. Now we do have things a little bit wonky, so let's go and move them around until we're happy with it. And by the way, the sketch that we're creating right now is for the interior of our sunglass case, because the outside is going to be driven by the inside, and the inside is based on making sure that the glasses themselves are going to fit inside this. So I'm going to take this bottom edge, and this is about where I want it to be. This is looking quite good. And I'm actually going to lock this down by using the fix or unfix command. I'm going to go and move this line in the back. We're going to go and move that forward. And I'm going to also use the fix or unfix command to lock this down. Now, if you haven't used that before, or you just don't like the fix or unfix command, you can also put dimensions to constrain those lines as well. That's perfectly fine. The next thing I'm going to do is I am going to add some dimensions. Maybe we'll define the angle here. And maybe I don't want to define it that way. Maybe instead I'm going to define it like this. And maybe I'm going to set this to something like 10 degrees. Looking good. Perfect. Now I do want to make sure that I have a flat area. And hold on just a moment. Let's move this out of the way. Looks like I have a little bit of a graphics card glitch. So this is a perfect time. We're going to just fix this, but nip this in the bud. I'm going to quickly save my file. And we're going to say started to make sketch. Perfect. I'm going to go and close this file real quick. We're going to go and reopen it. And I believe that little problem is going to be gone. Perfect. Let's go back and edit that. Now it's looking great. Now I want to make sure that I have a flat spot for me to be able to put magnets in. So I'm going to go and put a dimension here and say this dimension is going to be 10 millimeters. That's looking pretty good. Let's see if I can move this around, and I can. This is looking great. And maybe this would be a good time for me to start to put a dimension in. And we're going to put a dimension between these two areas here. And I like nice round numbers, or at least integers. So we're going to go and set that to 32. And that's looking good. And if you are already familiar with sketching, you're noticing that my sketch is turning from blue to black. And what I'm doing there is really I'm starting to define all of the information that you need about your sketch. I'm fully defining my sketch, or fully constraining it. And I think that's a really good thing because it prevents errors down the line. Now I am also going to go and add some tangencies here. So I'm going to go and add a tangency between this arc and this one, and this one, and that one. That's looking really good. I'm also going to go and move this over quite a bit. We'll clean up this area in just a few moments. And we're going to go and put a dimension between this line and this one. And I want here a gap. Now, if you're wondering to yourself, what kind of gap is Jason going to pick? Let me tell you that we're going to be very specific about that gap. That gap is going to have to be at least the thickness of the wood itself. So I'm going to type in here thickness, because we defined earlier a value for thickness to be the same value as the actual thickness of the wood. And I'm going to add 0.001 millimeters. And the 0.001, that's arbitrary. I just picked that at random, or somewhat random. Really, I'm just trying to have it be bigger than the thickness. By how much is up to you, and in my opinion, having that be a small number is a good thing. And I'll explain in a few minutes why it has to be at least thickness, and it'll actually become pretty clear on its own anyway, but I will show you. All right? So let's go and add some more information. I'm going to go and draw a perpendicular line right here, and another perpendicular line right over here. Perfect, and it automatically applied the constraints that I wanted. I'm going to pick these two endpoints and I'm going to make them coincident. And I'm going to go and trim this one right here because I don't need that either. And we're going to make these lines construction actually. I think that'll be better. Perfect. Now let's go clean up the top end of this particular case because it's looking a little bit funny. And this is where you might want to not fully constrain your design because this is going to allow you to have a little bit more leeway in how you want to make this. Now, I want to make sure, though, that I have at least the minimum bend radius. So here I am putting in a dimension, but if I want this to still be editable, I can actually come in here and change my dimension to driven. And now I actually can still modify my sketch, and it'll just constantly update me on what the value is. And what I want to make sure is that this is going to always be at least my minimum bend radius of 10. The last thing that is important to me here is I do want the end of this line to match up with this spot right here, and we'll go and make that coincident. And I'll go and actually fix this design just a little bit. That's a little funny. Let's go and fix that. And now we're talking. Now this is looking much better. Maybe I do want to fully define this. So I'm going to go and make this driving again. Maybe we'll set this to 30 millimeters, and I'll go and set a dimension to this arc as well. We'll make that 15. Nope, I think 17 might be a little bit better. That's looking much cleaner. So now I have a shape, and you'll notice that my sketch is all black or completely defined, fully defined, and I'm good to go to start actually making this in 3D. And remember that sketching is actually the fundamental skill that everything else in Fusion 360 is based on, so don't rush when you're sketching. Spend the time, learn how to sketch properly, because the value that it's going to bring to you later is going to be immense. So I'm done with this sketch. And what we're going to do here is not actually design the living hinge portion. We're going to start with the sides. And for that, we're going to use those construction planes that we made. So we're going to start off and create a sketch on this construction plane off on the side. And what I'm going to do is I'm actually going to project the sketch that we already made in the center. We're going to project it off to the side. And we're going to go and use Create, Project, Project. And you can see there's a shortcut for the letter P that would make your life a whole lot easier. I'm going to go and select Entities, and I'm going to pick all of the different entities in this particular sketch that are important to me. And that's going to be these portion right here. All right, and that's actually looking great. So I'm going to hit OK. Now I have a closed profile, and we're going to use that to actually make the side of this, this case. To do that, first I want to make a component. So let's go and say Create a new component. We are going to call this Sides. And the parent, I'm going to deselect it and automatically make sure to pick the top level assembly. And I like to deactivate it. I don't like to activate it right away, because instead what I like to do is to lock down the position so it's not going to move on me by accident. I'm going to hold Shift J, which is the shortcut for an as-built joint that we did earlier. And I'm going to choose the side component and my eyeglass case. And I hit OK. And now this component won't be able to move. And that's good. I don't want it to move by accident. Next thing I'm going to do is I'm going to activate this component, select that profile, and I'm going to extrude the shape of that part. For the amount that I'm going to extrude, or the distance, well, we already have a value called thickness. That's why we put it in our parameter table. And we're going to hit OK. And so now I have the side of my part. And that's looking pretty darn good. Now I do want to make sure that this is going to look even better, and I want my properties to be correct. So the next thing that I like to do is go into your bodies folder, right click and go under physical properties. And now we're going to go and set this to the type of wood that I'm using, which happens to be walnut. So I'm doing a quick find, and here it is. We're going to go and drag walnut onto my part, which now means that the weight of the part is going to be kind of close to what it should be with walnut. Now, I don't really like the look of the walnut in this case. It looks a little washed out, well, a little dark actually. And so what I'm going to go also do is I'm going to go and hit A for appearance, and I'm going to override the appearance of the walnut with one that I like better, which happens to be the 3D Cherry semi-gloss. I'm going to go and download that. Within a couple of seconds, it's downloaded. And I'm going to go and apply that to my part. And now this is looking much better and much more realistic. And we might have to do the same thing with the main component, but that'll be pretty quick and easy now that we've done this. Perfect. Now, you might have been wondering, why am I designing the sides first? That'll be evident in just a second. But first, let's go and make the other side as well. For that, I'm going to go and select this side. I'm going to hit Control-C and Control-V on my computer, and it's going to paste a copy of this particular design. To make things easier to position, I'm just going to move this over a little bit and hit OK. And now we're going to go and apply a regular joint. I hit J on my computer for joint. I'm going to select the very center of that component, the very center of this side of the component, and it's automatically going to put them next to each other. But I want them to be apart from each other. I want the second one to be the exact other side of this particular assembly. And so for the distance, we're going to go and drag this arrow a little bit. That makes it pretty clear that it's the Z that I need to adjust. And I'm going to type in interior length and hit OK. And now these are in exactly the right position. And if you compare this to the offset plane that we made earlier, you could see that this offset plane is actually falling on this surface perfectly, so I did a good job. Excellent. And I don't think we're going to need our construction planes for a little while, so I'll go and turn those off. Excellent. So now I have the sides. Let's go and build the center. And now we're going to start to get into the area of sheet metal. So let's go and see the sheet metal tools for a moment. And under sheet metal, you could see that we have a variety of tools at our disposal. But what I want to start with are the sheet metal rules. And here you could see I have a list of a lot of different materials. And two of them in particular are going to stand out for today's topic. And that is proof grade medium walnut ply, or plywood, and proof grade medium cherry ply. Now, the laser that I'm using is called a glowforge. I own this personally. This isn't owned by Autodesk. I keep it at my home in my office, which I like to call my laboratory. And this laser, the glowforge, is incredible. And one of the coolest things about it is that if you buy your material from the company that makes the glowforge, then they automatically give you all the right settings to actually laser it. And so I love using their materials, and they call them proof grade materials. And the one that we're going to be using today is their medium walnut plywood. And you could see here that I've already set up the thickness to match the 3.05 millimeters that we talked about earlier. And then I have a lot of other options here. And one thing that I didn't update that I probably should have is the bend radius. And you can see right now the minimum bend radius is set to 3.05 millimeters. But I can go and edit that really easily. And so we're going to go to bend conditions, and we're going to say that our bend radius, instead of being equal to the thickness, is actually equal to 10 millimeters. Perfect. Quick update. Now, we do have things like K-factor in here as well. And if you're not familiar, K-factor is a special number that determines how your material is actually going to stretch or contract as it's bending. And for now, you don't have to nerd out too far. Ignore the K-factor. It's going to be close enough to start with. And so leave that as is. But if you're even more advanced and you know what that number is, of course, you could go and input that number and be very happy that your results are going to be even more accurate. So that's my sheet metal rules, and I already have it set up. So let's go and create a flange. But before we do that, we want to have a component to go and add that flange. Now, theoretically, you could add flanges to your assembly, and that's fine, but I would say that my best practice is to always create a component for each and every sheet metal part that you're going to design. And that's actually very important because some of your components might have different sheet metal rules. And you can't do that if you're just making your sheet metal flange at the assembly level. So in this case, we're going to start off just like we did with the sides, and we're going to say, let's make a new component. We're going to choose for the parent to be the eyeglass case assembly. We're going to name this living hinge. We are going to not activate the component. We're then going to go and create an as-built joint between the living hinge and the eyeglass case and hit OK. And now we're going to go and activate the component itself and create our flange. For this, I'm going to go and select the exact same sketch that we created earlier. And I'm going to go and drag my arrow, and you're going to see that it's going to turn this into a 3D part. Now, right now, it's creating this in one direction, but I could also change that to symmetric. And we're going to make sure to select our proof grade walnut that we were using before, or that we created before. But this is where the distance is going to be very important. And the distance is going to be important because, and we're having a little issue. Let's go and use this for now, and I'll go and switch this in a moment. If we look at this from a front view, if I were to type in the value for the interior length, let's go and do that. And we used this before, interior length. And in this case, we're going to do it divided by 2. And it's looking pretty good. But if I zoom in, you'll see that this doesn't actually reach past where I want it to. And that actually kind of makes sense because when we created our planes from the beginning, they were set to the interior width, not the exterior width. And in this case, I want this to be the exterior width. So luckily for us, Fusion 360 uses equations. And so not only can I put in interior length divided by 2, I could also add some parentheses and add an additional part of our equation, which is that we're also going to add the thickness to it as well. And now it's automatically going to be the right size. All right. Now we're going to go and figure out why we had our error. and we're going to go and look at our more info, and it's giving us an issue. And I think I know why, so we're actually going to go and bypass this very temporarily. We're going to go fix our sketch, and then we could actually go and change our sheet metal rule very easily. So let's go back to our sketch. That'll be this one right over here. We'll go and edit this. And I'm going to go and change two things to make sure that we don't have our problem. We're going to go and make sure that our gap is just a little bit bigger than before. Maybe we'll go and make this 3.01. And I think that's actually pretty good. I think that should work. And actually, I'm also going to increase these radii just in case. We'll make this 12. We'll make this one 12, because remember that just because I said earlier that the minimum bend radius is 10 doesn't mean that I have to push my limits and get to that minimum. 12 is just going to be safer than the 10, and that's good. And this is also looking good. Let's go into our living hinge, and we're going to change our sheet metal rule, and we're going to use our proof grade walnut. Perfect. And now it's actually updated, and so this is actually great. We are going to go and fix, just like we did before, our physical material to match the walnut that we want to use. That's looking great. And then I'm also going to go into our appearances, and I'm going to set this to be our 3D semi-gloss cherry. And now this is looking great. Now, what I'd like to do is to test that this is unfoldable, right? Because after all, my goal at the end is going to be to make a flat pattern. Now, there are two ways to do this. One is to create a flat pattern itself, and we could do that by saying, let's create a flat pattern, choose a flat surface like this one on the back and hit OK. And now you're going to see that it flattened, and it's going to show us all the different bend lines that I need for this particular design. That's one way to do it. The other way to do it, and we'll go and delete that flat pattern for now. The other way to do things is going to be that we're going to go and look at unfolding this design. So we're going to go under Modify, Unfold. I'm again going to pick a stationary face, and I could choose which of the bends I want to test if they'll unfold. So here's a great example. I'm unfolding the top, and this is realistically what I'm going to do to actually take the glasses out. So this is a perfect simulation of what it's going to look like when I open and close this design. Excellent. All right, and instead of deleting this one, we're actually going to use this in just a little bit. But this is looking great. I'm really happy with this. Let's go and refold that. So let's go and give this a little bit of pizzazz. The first one is going to be, we're going to add some magnets. For that, I'm going to go and activate this particular component, the living hinge. Select this face, and we're going to create a sketch on this face. I'm going to project the actual face that's right over here onto my model. And now that I've projected it, I'm going to use the sketch from now on, so I can actually hide the body. And I'll also hide the glasses because I don't need those as well. And let's go and look at this up close, and let's add our magnet holes. Now I want these magnet holes to line up, so I'm going to go and add a line from the center rather, of this line to the center over here. I'm going to go and turn this into construction. I'm actually going to do the same thing for the entire perimeter. I just used the shortcut, the letter X, but you could also hit construction over here on the right. I'm going to go and draw some circles right over here for our magnets, and we're going to take a quick pause to talk about magnets. Perfect. So I need to get magnets to fit in this particular project, and how I'm going to do that, there are a lot of different ways, but the way that I like to do that is by having magnets that I could choose from. So this is an assortment of magnets that I bought on Amazon. It gives me about, I think it's 20 of each magnet, and I get something like 5 different sizes. And so I can pick through this and figure out which one of these has the right diameter for my particular project or the right thickness for my project. And I can even try pulling them apart and see which one has the right pull strength for the project that I'm doing. In this case, we're going to be using the smallest magnet in here. And I already know the dimensions, so we'll go and put those into Fusion 360. But I wanted to show you that you could just buy an assortment of magnets like this that I keep at my home and use that to be able to figure out which one you're going to use for this project. Excellent. All right, jumping right back into Fusion. Here I have my circles. I'm going to put in a dimension for one of them, and this one's going to be 5.8 millimeters. And then for the position of this, I'm going to apply a symmetry constraint by adding a center line in the middle and then using the symmetry constraint. Voila. And then I'm also going to go and put a dimension here from the side wall to the magnet itself. And you could see here that right now this dimension is actually going to be from the side wall to the center of the magnet. And now that might be what I wanted, but there are plenty of cases where that's not at all what I wanted. So here's a quick tip for you. Let's go and delete this dimension and make a new one. I'm hitting D for dimension, but before I select anything, I'm going to right click and instead of choosing to pick the circle or arc center, which is the default, I'm going to pick the circle or arc tangent. Now I can select the side edge and the circle, and it's automatically going to let me pick whether I want the inside tangent edge or the outside tangent edge, and this is exactly what I did want. Maybe I'll set this to 12 millimeters. And of course, it's going to update the other side as well, and that's looking really good. Now if I show my body, I can go and use this circle as well as this one right here, and we can go and make an extrude cut through our model. Let's go and show that from the side. We'll go and make this maybe 20 millimeters deep, which is more than enough for our needs. And now I see that I have my through holes. Now, whenever I'm making a big change to my model, I do want to make sure that it's still going to unfold and I'm not going to have any problems. So let's go and test that out. We're going to go and again do an unfold, select our back surface, select our bend, and you could see that everything is unfolding perfectly, right? Of course, I could also come in here and edit this and say, you know what, I want to unfold everything. And again, this is looking much closer to the final flat pattern that I want for this design. Perfect. Let's go and refold those faces. And I don't need this for now, so I'll just go and delete that. Perfect. So now I have the magnet holes. Maybe I also want to go and put my text on the front. So I'm going to go and create a sketch. And you know what? Instead of creating a new sketch, let's actually use what we've already created. Let's edit our sketch that we've already made. We're going to hide our bodies. And maybe the height of the text is more important to me than the width of the text. So I'm going to go and make a quick rectangle here. And I could set a dimension from the bottom of this edge to here. Maybe I want that to be 1.5 millimeters. And I'm going to do the same thing over here. And instead of typing in the same value, I could actually click on the first one. And now they're going to be linked to each other. So if I change this value from 1.5 to 2.5, the top is going to change as well. Let's go and put that back to 1.5. And this is looking really good. We're going to go and make that construction like so. And this is looking great. Now we're going to go and bring in our actual image. So I'm going to go and say insert DXF because I already have this from another file. I'm going to select the DXF from my computer. We're going to go to my desktop. Here I have files for today's design, and we're going to bring in my Wise Wizard logo. You could see that it's coming off in space in a different location, and my units are off. That probably has something to do with it. So I'm going to go and select this to be millimeters. That's looking much better. And now I might want to go and place this exactly where I want it. So we're going to go and zoom out a little bit. Perfect. We'll go and place this. And we'll actually hide our body. We can actually turn on the sketch that we had from before and make sure that I place this in the right position. Now, for today's lesson, this is going to be close enough. So I'm actually going to be happy with this. We'll leave that there. And we're going to go back to our body. And we're going to go and take this shape and we're going to extrude cut partially through our design. Go and select these areas right here. And by the way, if I didn't have this in the right position, I could use the move copy command and move my sketch entities. I could also rotate them and do a variety of different things to it. We're going to go and use an extrude. And for our depth here, we're going to go minus, and I'll go 0.5 millimeters. Perfect. And now I have my logo on the front. By the way, if you're wondering what Wise Wizard is from, it's something that I made up. I thought it was cool. I just wanted to have a cool logo on all my stuff. All right. So let's go and continue our design. Now I'm not going to focus on the lightning bolts that you've probably seen on this design, right? I have lightning bolts on the side as well. I'm going to skip that because it's going to be the same process as you see right now for the Wise Wizard on the front. We're going to focus on the latticing that is the key for this actually bending, right? Because we don't have a lot of time left. I don't want this video to be too long for you guys. You could always re-watch this on high speed, 1.5 times, and it'll go much quicker, but I don't want this to be too long regardless. So let's jump right back into screen sharing. And let's get into the lattices. So for the lattices, we're going to go and do a whole bunch of different stuff. The first thing we're going to do is we're going to go and unfold this design. I'm going to go and choose the back surface. And for the bends, we're going to unfold everything. Perfect. Oh, actually, you know what? I completely skipped a very critical step, so we're going to have to go back for just a moment. Let's undo that. We'll go and delete this, and we'll be back here in just a moment. Actually, we can go back in time using the timeline, and we'll come right back here in a moment. So it is important that I have a connection between these parts on the side and the rest of the living hinge. Otherwise, this won't stay together. My case, actually, you can see here, it has no glue in the joints whatsoever. This is actually a press fit, and everything fits together really, really well and stays together really well. So we want to put those same shapes in here as well. So for that, we're going to go and design this on the side view. We're going to go and show our side piece. We're going to go and design on this particular plane, that face. And here we're going to see that I have a couple of flat spots. I have a flat spot here, I have a flat spot here, and I have a flat spot there. And that's what we're going to use to create our joint, right? So for that, I'm going to go and project these regions right here. Perfect. And I'm going to hide our bodies because we don't need that. And we also don't need this. And what I'm going to do is I'm going to break them up into different sections. So first thing I want to do is measure the distance between them. And it looks like this one is 10 millimeters, and that makes sense because we actually set it to exactly 10. This one over here is 6.446 millimeters. And this one here, let's go and reset our snap. This one is something like 18 millimeters. This is perfect. So what I really like to have is I'd like to split these up into 3 pieces each. I can definitely do that here, but I'm going to have trouble on these two because I want each section to be about 5 millimeters. So what I'm going to do here is we're going to exit out of our measuring, and I'm going to split this one up into 3 sections. Perfect. And I'm going to go set our distance to 5 millimeters. Same thing over here. And over here at the bottom, we're going to go and split this into 2 right down the middle. And we're going to do the same thing over here. Perfect. All right. Now that I've done that, we're going to go and show our body again. And I'm going to choose to take this one, this one, this one, and this one. And we'll do an extrude here. And for the extrude depth, we're going to choose to extrude all the way until we get to that back surface right over here. We're going to join this together and say OK. And now you can see that I have a little bit of a funny shape on this piece. And of course, the same thing on the other side because I designed these as 2 instances of the same component. They are the same thing, just in 2 different locations. And so this is looking really great. Let's go and show our living hinge. And now what I want to do is subtract one from the other. So what I'm going to do is I'm going to activate our main living hinge. And we're going to do a combine command. We're going to target our living hinge. And we're going to use these side pieces as our tools. And we're going to cut, but we're going to make sure to keep the tools so that they're not deleted. And now you could see that my living hinge actually has these cuts in it. That's what I wanted. So if we go forward in time just a little bit to show where we unfolded, now our design actually has these little pieces in it that are important for everything to actually fit together. So we're in a really good spot so far. Let's go and design our living hinges. So I'm going to hide our side pieces. We don't need those. And we're going to activate, we actually already activated our main living hinge. And so we're going to go and create a sketch. And we're going to use maybe this plane right here to create a sketch. And we're going to start off and just do the living hinge from this edge right over here where my mouse is to this edge. And that's the only thing we're going to do at this point. So we're going to project this edge right over here, as well as this edge. Actually, we'll just do these 2 points. We'll make it easy on ourselves. And I'm going to say OK. I'm going to hide the body, and I could just use the sketch itself. I'll go and connect these two together. And we're going to make these construction lines as well. And I'm also going to add a center line. I'm going to go and draw it a little bit off center. Makes it easy to know that if it did this correctly. We'll go and add our symmetry. And I'm also going to make a vertical constraint between these two so that everything is nice and symmetrical. Perfect. Now, we talked a little bit about our patterns and how we're going to do this. And this is where we're going to get to the really, I'll admit, the hard stuff. If you thought what we were doing before is advanced, this is going to get just a little bit more advanced yet, but I think you're going to find that this is worth it. We are going to go back to our parameters table and add some new parameters. The first thing I'm going to do is add a dimension for this height. It's going to tell me that this is only going to be a driven dimension, and it's going to be 69.334. We're going to go into our parameters table, and I'm going to make one here that says total lattice height 0, 1. And this one is going to be equal to the number that we had just specified, which I hope I remember correctly, is 69.334. And if I got that incorrect, I'll cheat a little bit. Oh, I did get it right, 69.334, perfect. Now, to note, the reason that I had to enter that manually is because right now our parameter table does not let driven dimensions, like the one that I created a moment ago, drive other things. They are driven, not driving, so they cannot drive other things. So I'm cheating the system just a little bit. It's a little workaround of my own that I came up with, where I'm just making a parameter that's matching that same value. And if at a later date I change my design slightly and this value changes, I will have to come in here and update this number, but that will still drive quite a bit in my design. I am going to add another parameter here, and this is going to be called lattice gap. This one's going to be set to 6 millimeters. And by the way, if you're wondering where I got this value, this is literally from the swatch that we looked at earlier. And if I look at the 1.5 millimeter swatch, which is somewhere right over here, if I zoom in and take a measurement, that's the gap between these different lines you could see here. And so I'm just going and using that same thing over in Fusion. And so far, so good. So we're going to go and draw our geometry. I'm going to go and draw a line like so, another line, and I'm intentionally drawing them a little bit crooked. That's on purpose, actually. And I'm going to draw a second line right over here, and, sorry, a fourth one, and a fifth, and now I'm done. Now, the reason that I drew them at an angle is because I didn't want any constraints to be added automatically. I want to set the constraints myself. So we're going to go and add them. I'm going to set collinear between this line and that, between this line and this one, between this line and this one. I'm going to set my dimension between these two. That's the gap that we talked about. And I'm going to set that to lattice gap. I'm going to do the same thing over here, lattice gap. Now we're looking really good. I'm also going to make these lines a little bit longer than my actual model because I want to make sure we're burning all the way through. I'm going to set that to be 0.5 millimeters. And I'm going to move this one across and do the same thing on this side as well. 0.5, nice. And you could tell that these lines are still movable at this point. Okay, I'm going to go and add a center line, let's see, right around here. We'll go and make this vertical. And I can go and say this center line is going to be in the center of this line in particular. Now this is also centered. That's going to help me quite a bit later also. Now we're going to set this line to be horizontal, this one to be collinear. We know that we want the gap between these to be 6 millimeters, or our gap that we talked about earlier, lattice gap. I also want to make sure that this is symmetrical, so I'm going to go and add symmetry here from left to right. Oh, and I have to pick the third line. Now it's looking good. And in terms of the distance on the end, I know that this, from here to here in width, is also going to be the same gap. We'll set that. And we're going to do the same thing on this end. gap. Perfect. So we're mostly good to go here. Let's go and look at this further. I know I can change the height, but I can also move this around, and I don't want to be able to move that around exactly. So I'm going to go and use another geometry trick. I'm going to draw a line from the very center of this one to here, and another one from the center of this line to there. Set these both to construction, and geometry trick, if I set them to be equal to each other, it's automatically going to center this line. So now this one can't move left to right anymore, and the only thing that I could move around is the height right over here. Perfect. So now we need to go and add another variable, actually several more variables. And this is where it's going to get a little bit confusing, but I'm going to try to make this as clear and as simple as possible. We're going to go back to our parameters table, and we're going to add one here that's going to be called vertical lattice gap 0, 1. And for now, I'll set this to be 1 millimeter, actually 1.5 millimeters, because that's what we really want the gap to be close to. I'm also going to add a variable called number of vertical lattices, number 0, 1. This is going to be a unitless number, and I'm going to set this to, let's say, 30 to start, and we'll go and work on that. And we're going to make, let's see here. Oh, we're going to change this vertical lattice gap, and instead we're going to change this from 1.5 millimeter. We're going to change this to be an equation, and this is where it gets complicated. We're going to make this equal to the total lattice height, that's the space that the lattice is going to fit, divided by the number of lattices. Oh, hold on, I misclicked. Let me go and try that one more time. Divided by the number of vertical lattices, and hit enter. And the value at this very moment calculates to 2.311 as the gap. Let's go and take a look at that and see what that's going to look like. This value here is going to be set to be that vertical lattice gap, and that's 2.31 millimeters. But if you guys remember, when we had our actual swatch and we bent it, we were doing all of this and saying, you know which one I wanted? I wanted the one that was 1.5 millimeters in gap. Now, if I set my gap to be exactly 1.5 millimeters, the problem I'm going to have is that the top line in this swatch and the bottom line might not line up perfectly with the part that I'm actually making. So I want it to be as close as possible, but it's unlikely to be perfect. But 2.3 is definitely pretty far off what I really want. So let's go and see if we could fix that. We're going to go back to the parameter table, and actually let me go and show you this view. That's the wrong view. Let's go and look at it like this. I did the wrong view again, just a moment. There we go. So I'm going to move this over so you're going to be able to see this as we change it in the parameter table. So we talked earlier about the number of lattices is going to be 30, and I made that number up. I could have picked 10, I could have picked 100, wouldn't matter. Whatever I pick in here is going to automatically change this gap. So all I have to do is change this number until it gets really close to 1.5. So you can see I'm getting closer, getting really close now. 46 is going to get me 1.507. 47 is going to get me just under. Now at this point you get to choose. Do you want to be a little bit under or do you want to be a bit over? I would say either is perfectly fine. It's entirely your choice. Or you could just go whichever one is slightly closer. So maybe I'll go with 46. Perfect. So our gap is now 1.507. Perfect. The next thing I'm going to do here is I'm going to add the same lines that I have on the top on this edge right here on the bottom. And I'm going to make this easier on myself. I'm going to use the mirror command. I'm going to mirror this line, and this one. I got to select it. There we go. And I'm going to use this symmetry line in the middle to actually do the mirroring, and that's looking good. Now, you might be wondering to yourself if I'm going to do the pattern of this particular set right here, and I'm going to tell you no, I'm not going to do the pattern here. In fact, I'm not doing it here on purpose, and there's a reason. If any of you guys have ever design something with a really complicated sketch, especially when you start to include a lot of symmetry and a lot of patterns and a lot of entities, one thing that you'll find is that you make a small change to the sketch and you have to wait a really long time for everything to update. I know that that happened to me when I first designed my eyeglass case, and it was really frustrating. But luckily, you're going to have a little bit of a tip here, and that is that you can design this as separate sketches. And as a result, you can actually control how much of the math is recalculated every time you make a change. So let's go and take a look at that. So if I come in here and I change something on my parameters table, what is going to change in this sketch? The width is going to change, right? Because I have this value of 6 in a bunch of different places. And I have the gap over here, but nothing else is really going to change. If, however, I have a pattern that actually makes like 500 different lines, all of those lines are going to recalculate every time I make a change. And that would drive me absolutely crazy. So instead, I'm going to hit stop. I'm going to create a new sketch. And the first thing I'm going to do in this new sketch is I'm actually going to project the original lines that were created using my parameters. And again, I know that this is going to sound crazy to most of you out there, but this is on purpose and there's a good reason for it. We're going to go and select this line over here. And you'll notice that I'm having trouble selecting the line that I want, but I can actually select and hold and it'll give me choices, and I could select exactly what I want. I'm going to go and do that again, and there we have it. So I'm going to select all of that and hit project. Now I can hide the original sketch, and you'll see in pink I have all of the entities that I designed in the first sketch, but now they're projected, which means that if I change something in the parameter table, it's really editing it in the first sketch and then showing up in the second. And this will make a little bit more sense as I go. I'm going to go and add a pattern here. We're going to go to Create, Rectangular Pattern. I'm going to choose for the objects these lines that are right here at the top. That's all of them. I'm going to go and drag this arrow down, and you could start to see the pattern forming. I'm going to change the distance type to spacing, and here's where it's going to get interesting. This is again going to work with our equations. So the quantity that I want, we actually know that. We made a value called number of vertical lattices. And you can see now I have apparently something like 46 lattices all generating. This is exactly why we're doing this in a separate sketch instead of the original. But the spacing is totally off. And because of that, nothing lines up the way that I want. But for the distance, I could actually come in here and we have another value that we could type in that we created earlier. And that distance is going to be the vertical lattice gap. And now everything updates, and if I zoom in, you'll see that it actually lines up perfectly. And that's awesome. Now, there is a reason. Oh, actually, I made a mistake. Let's go back and fix that. Let's go back to our parameters here. We're going to go and edit that. And I believe the distance is actually vertical lattice gap divided by 2. Let's go see if that's what we get, if that's what I wanted. No, that's not what I wanted. Let's go back and do that one more time. We're just going to reverse things, and I think it'll be great. We're going to make this the full value. And then over here, we're going to go and set this to be divided by 2. And now I think everything is going to line up great. Perfect. Now, hold on. Let's fix that one more time. This is, by the way, the fun about doing things live for you. And so we're going to go and fix this. I refuse to have this be incorrect. We're going to go and divide that by 2. And let's see if we got this right. And something still seems off, so let's go and fix that. I see the problem. Our quantity does need to be correct. Does need to be. I figured it out. Thank you guys for bearing with me. Our quantity is going to be the full value, and our distance is not going to be the vertical lattice gap divided by 2. My mistake, it's going to be times 2. And now it works. Perfect. Now, because I had a little bit of fudge there, I do want to make sure that we're going to go over the exact numbers one last time and have this be correct. Finally. So for the quantity, we're going to do the number of vertical lattices divided by 2. And for the distance, we're going to use the vertical lattice gap times 2. And now this actually lines up exactly how I wanted. Again, this is the fun of live demos. And this actually makes sense, right? Because the quantity should be divided by 2, because whenever I am doing my pattern, I'm actually patterning 2 of these at the same time. So I want to divide that number by 2 so I get the exact number that I really wanted. And the gap is going to have to be doubled, because when I move this 1 unit over, I'm going to have to move it twice this distance. Really, I'm moving the distance from here plus this, which is the same as this 1 times 2. So that makes sense. So here I'm going to go and say that looks good. And theoretically, I'm actually good to go. Now, I might want to do this, I would have to do this 2 more times for this particular design. Because if you look at the original flat pattern, let's go and take a look at that. We'll show our body. This area here is really just a part of our design that needs the lattice. I also need a lattice from here to here. And I also need the lattice from here to here. Now, our webinar is actually running a little bit long today, so I'm not going to do this 2 more times, but I think you guys get the idea that I could easily do this 2 more times and just repeat the process. But what's important is that instead of editing the sketches you've already made and adding more lattices to it, I'm going to create a 3rd sketch and a 4th sketch for the lattice in this area. And I'm going to create a 5th sketch and a 6th sketch for the lattice in this area. And I know that that sounds like a lot of sketches, but again, that's on purpose, because when you're doing things like patterns like this, it's going to be very resource heavy, and limiting the amount of rebuilding when you make a change is important. So if I do need to make a change to my lattice gap or something like that, what I'm going to do is actually go back in time 1 step between the sketches. And now if I make a change to my sketch of just these lines at the top, it's not going to go and try to rebuild all the actual patterns after it. And that to me is really important, because it's going to make my life a whole lot easier. A lot easier. The other thing to note is, how are you going to make this look in 3D, right? How are you going to make this look in 3D? And by the way, I also do notice I made a mistake here. I'm starting the lattice a little bit too high. It should actually start right here, right? If we had a little bit more time, I'd go back and show you how to fix that. That's pretty quick and easy, but just I recognize that I made a mistake over here, and that's okay. Now, for actually creating the toolpaths for your laser or for cutting this, the sketches that I made are actually perfectly fine. Let me jump to the finished part for a second. And if I go and I scroll way ahead in this particular design, you'll see that over here, this is where I created all of my patterns for the different lattices. We'll go and hide everything that we don't care about, like the disc magnets and the cork and the side panels and things like that. And here you're going to see, if we show the sketches, let's go and turn those on. We're going to turn on just, let's see, we're going to turn on this one. All right. So if we look at this here, this is actually what I'm using to drive the laser. I don't need to actually have the cuts in the 3D model itself. I could actually use this to drive it. In fact, if you go to the manufacturer workspace, we'll go and refold this. If you go in the manufacturer workspace and you look at how I created my toolpaths, we'll go and regenerate these really quickly. You'll see that these toolpaths are actually based on the sketch, not based on the 3D model in this particular case. And here you could see that right there. But I might want to make this look really beautiful so that I can make really high resolution renders, or I could just anticipate if there are going to be any problems in my design. So let me show you how we're going to do that. We're going to go back to the design space, and we're going to go a little bit further forward, and we're going to go right about here. Perfect. And what I'm going to do is I'm going to unfold this design using the sheet metal tools. We're going to go and unfold it using this back surface, just like we did before. And I'm going to unfold all the bends. Give that just a moment to calculate. And then once I do, I'm going to use extrude, but instead of extruding a solid, because a solid requires a closed sketch, we're actually going to go and extrude the lines themselves as surfaces. And that's going to allow me to then thicken those surfaces and even do a Boolean cut using those thickened surfaces. And you'll see that in just a second. And actually, Fusion's taking just a little bit longer than I would like to be able to go and unfold this. So, oh, perfect. Just in the nick of time. Perfect. So I have this unfolded, and now we're going to go and add our cuts. For that, I told you we're going to go and use the surface tools, and we're going to go and choose extrude. Looks like I have a little bit of lag here. Just a moment. There we go. All right, so I have my sketch, and I'm going to go and use the surface tools. We're going to go and use extrude. I'm going to go and hide the bodies itself, and I'm going to go and extrude all of the entities that are inside this particular lattice right here. I'm going to go and give them a distance, and for now the value doesn't really matter. I'll go and set this to maybe 100 millimeters, and we'll do this in both directions, and we'll say OK. By the way, we do want to see the bodies, so we're going to go and show that real quick. And here you can see that I have plenty of different surfaces to look at. Now I can go and thicken those same surfaces. I'm going to go and select all of those surfaces right here. Perfect. And I'm going to choose to thicken them symmetrically. And for the value, we're going to go and use that kerf value that we talked about earlier. And we're going to actually divide that by 2 for now, so it's a half kerf in each direction. And now I'm going to go and have a whole bunch of solids. I can then go and delete my surfaces. I don't actually need them anymore. We'll go and remove them. And now all we're going to be left with are the solids. I could also go and show my sheet metal part. Let's go and show that. And now we're going to do a Boolean cut using those solids. We're going to go and mess with this particular part, the living hinge. And for the tool bodies, let's go and hide pretty much everything else that we don't care about here. We're going to go and hide our sketches, and we're going to go and hide everything else that we don't care about. And we're going to even hide this for a moment and select everything that's in the graphics window. And we're going to get rid of those tools after we cut, and we'll say OK. Now we're going to go and calculate a little bit of a lengthy compute on that. And when I show it, you're going to see, if I zoom in, you can actually see the slice of the individual laser lines, right? And the cool part is that now that I've done that while it was unfolded, I could actually go and refold this design. And you'll go and see that here. We'll go and refold this design, refold it right here. And you'll see that it's going to go and take those different cut areas, and it's going to still show it in its 3D state, in its folded state. It does take a moment to calculate this. I did say pretty much early on that these lattices take a lot of compute time, which is why I was showing you how to be able to avoid the excessive compute. And you could see this living hinge is actually 3D modeled, and that's actually looking really great. Now, I only showed you how to do this for one of the 3 lattice areas, and so you would do that for each of the different sections, and you'd end up with the final result that has all the different lattices in it. If you recall, when I was creating my parameters earlier on, I was putting in numbers at the end. You know, I had total height, total vertical height 0, 1, lattice gap 0, 1, and so on and so forth. And so you're going to do the same thing for each of the different areas, calling them, you know, lattice area number 2, lattice area number 3, because each one is going to need different numbers to it. And once you do it for all of them, you're going to have the full lattice. So the last part we're going to show you today is how to take that and actually send it to your machine to actually create it. So let's actually go and we're going to delete all of the changes that I made to that particular part. we're going to go and reopen this completed design, and I'll show you how we're going to go and create those toolpaths. We're going to go and jump from the design workspace over to the manufacture workspace, just like so. We don't need the 3D model. If you recall, the 3D model is really in this point just for aesthetics and not actually for the toolpaths. So in this case, we're going to go and show the model. We're going to go and hide everything that I don't care about. So the cork is going to be gone, or in my case, I used denim. We're going to hide the bodies themselves, and what we're going to show are the sketches that I made earlier that are important. I made a sketch for a front view of the outside shape of the design, including the text that I wanted on the design itself. And I also made a sketch for each of the lattice patterns. You could see those here. We're going to go and use this one, and this one, and this one. All right, so this is all of them. And we're going to go, and you'll notice, by the way, that I have the side pieces also here nested together. I did the nesting manually. All I did was copied the components, put a new joint to put them where I wanted them, and then I did a projection of a sketch. Sorry, I made a sketch, and in the sketch I projected those parts to give myself the outline as well as the lightning bolts. And so now I have everything all together in one place, all as sketches, and now we can go and actually put the toolpaths on. I'm going to go and create a new setup, and for this setup we're going to go and do cutting for our toolpath. I'm going to go and look at my coordinate system, and I want to make sure Z is facing the right direction. So I'm going to go and select a new Z axis, and this is looking much better. I'm also going to then go to the stock, and I could choose whatever size stock or sheet I'm actually going to start with. So in this case, we're going to go and use a fixed size box, and we're going to go and say that maybe the width is going to be 19 inches. The height is going to be maybe 11 inches. And the Z is going to be something like, 5 millimeters or something like that. And I'm going to say OK. It is going to warn me that the Z height is less than the height of the selected model, because what it's looking at is the 3D model, whereas I'm actually only using the sketches, so I'm going to ignore the warning here. And then I'm going to go and say, let's make a 2D profile for different things that I'm going to do here. And this is where you get into some of the nuances of laser cutting, where I'm going to want to choose what order I'm going to cut different things. So maybe I want to do the engraving of the lightning bolt or the text before I do the cutting of the lattice, or before I do the cutting of the outer perimeter. So the first thing I'm going to go do is choose what I want to do. In this case, I'm going to go and vaporize or etch the lightning bolts, and I'm going to go and choose this. You'll notice that the arrow here is on the outside of the lightning bolt, and what that's doing is it's applying kerf offset so that you get the exact size that you want. But for this particular scenario, I don't actually want a kerf offset, so I'm going to go over to the passes area, and for the sideways compensation, I'm going to put it at center, which is the same as not using kerf compensation. I'm also, for the geometry, going to add the Wise Wizard logo, and I can go and grab these really quickly. And I'll skip the other text for now because it'll be the same thing for that, but this is a great example. Perfect. And we're going to say OK. And it automatically is making the toolpath for me for laser cutting this particular area. And you'll notice that I set the Z on the back side of this particular part because the way that we were unfolding the model, the text, the seeing is believing and the Wise Wizard were all on the back side. So actually we're going to look at this as a back view to see what's really going to go in the laser. We're going to go and do another 2D cutting operation. We're going to go and select these individual lattices. And I'll admit you do have to select these one at a time, and that is a little bit time consuming. So I'm just going to go and select some of these for now. And then we're going to go and make sure we're going to cut all the way through our model. Under passes, we're going to put either left or right compensation, doesn't matter. We want center for this because we're going to have the laser be centered on these lines. And we're going to say OK. And imagine you were doing that, of course, for all of the different lines. And then lastly, we're going to go and do one last one here, 2D profile. We're going to have this one be also cut all the way through. But for the geometry, we're going to select the outer profile. And this one is important that you're doing your compensation. I want to make sure the arrow in this case is on the outside of the part. And I want the passes to be either left or right. Either one will give you the same end result in this case. The key is going to be that it's going to move the laser over so that the final part that comes out of the laser is exactly the dimensions that you want. Whereas if you were to use center or no compensation, you're going to end up with a part that's slightly smaller. And one last thing that's important is you're going to want the compensation to be in computer instead of in control, so that it's all calculated through Fusion 360 as opposed through the controller of your laser. And now you're good to go. So I'm going to go and do this once for the outer profile of this part. I'm also going to go and do this one more time for the profile of the side pieces. I'm going to make sure the arrows are on the outside. Again, make sure that my compensation is in the computer and say OK. And now I have a full set of operations that I can go and post-process. I'll go and skip to the one that I've already completed. That's this one right over here. We'll go and regenerate those toolpaths, and you'll see that I have a full list of toolpaths for all of the cutting here. And when I go and I choose to post-process this, I'm going to use the post-processor from my machine. In this case, as I mentioned earlier, I am using a glowforge. So I'm using the custom post-processor for the glowforge, created by Gareth, or at Gareth if you're on the glowforge forums. And we call that the colorific post-processor. And when I go and I post this, it's going to create an SVG file that my laser is going to be able to understand. And if you want to see what that looks like, again, we'll go to Illustrator, we'll jump to the other file, and it will look exactly like this. The only difference is if I turn on my preview with the colors, each color here is going to correspond to different operations for the laser. So maybe I'm going to be etching the green text first, then the blue text next, then maybe I'm going to go in and laser these light blue lines for the lattices themselves. Excuse me. And then we're going to go and cut the outer perimeter, and we're almost done, right? So Fusion 360, in short, is going to allow you to be able, to design your parts in 3D, even when those parts are going to be ones that are going to be starting as a flat shape. And that's an incredible thing to do. Excuse me. If you recall at the beginning, we talked about how do you go from an idea to a flat pattern without guessing. And Fusion 360 is going to allow you to design the part in 3D, unfold it into a flat pattern of your choosing. If you want to simulate it with the actual cuts, you can do that. You don't have to, as you saw in my example. But if you do want to simulate it with the cuts, you can do that, and then you can make beautiful renderings of your design to show off what it looks like before you ever make a real part. But the key is that by doing a little bit of advanced preparation, and that advanced preparation was creating some swatches, figuring out the minimum bend radii, and then applying those as well as some equations in Fusion, you can create anything that you can think of. This particular living hinge eyeglass case is just one example of that. And so I want to thank you guys all for your time today. I've got to run. It was a little bit longer than I anticipated, but I hope you guys all enjoyed getting to learn from me today. I look forward to teaching you guys about another advanced topic next time. And in the meantime, thank you again and have a great day.